We now begin a very important idea in calculus, and that is we've been taking derivatives. For example, y equals the natural log of x, and then we can take the derivative, which is 1 over x. But now anti, meaning to the opposite, what if you were given the derivative, then go backwards and find out what was the original function? So knowing the rules for derivatives and knowing some basic derivatives, like the derivative of natural log is 1 over x, the derivative of sine is cosine, things like that, are going to become very important when doing antiderivatives. Here's an example of it. With secant squared, you just have to think to yourself, well, somebody took the derivative of a trig function and they got the answer secant squared. So if the derivative was secant squared, then what was the original function? And so you can go through your mind and say, well, the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of tangent is secant. Oh, there it is. The derivative of tangent is secant squared. So that's the antiderivative. In Math 3b, you'll have more specific rules about how to find antiderivatives. Here it's basically use what you've already got. So this one, speaking of what we've already got, this one can be rewritten as x to the negative 2. The 1 over x, we don't need to rewrite. The secant squared, we don't need to rewrite. So there's the function. And in a way, you can think of it as, well, somebody has taken the derivative and they got this, then what's the antiderivative? Okay, so we've established that this one came from someone took the derivative of natural log. This one came from somebody took the derivative of tangent. And then for this one, well, when we have things like the function is equal to x to the 7th, then to take the derivative, you multiply by the 7 and then subtract 1 from the exponent. Well, to go backwards, you do the opposite. Instead of subtract 1, you add 1. And instead of multiply, you divide. So this one is going to be x to the, no, add 1 to the exponent, and then divide by that number. So I'm officially changing that to say the g prime is equal to this, and then the original function g is equal to this. There's only two small things. One is, if this would have had, say, plus a 17, then when someone takes the derivative, well, the derivative of 17 is 0, and so this one had a 0 there, so maybe there was a constant there, and nobody knows if it's 17 or 1700 or what for the constant. So often what we do is just say plus c, a constant. So the other thing is don't leave any negative exponents, so it's going to be the antiderivative is negative 1 over x plus the natural log of x plus tangent and plus a constant. One of the great things about antiderivatives is you can always check your answer yourself by taking the derivative and seeing if you end up with that. And you will.